right, so neural networks. You want to see them in action, right? Not just all the theory.
Absolutely. And, today's deep dive, well, it's pretty special. We're going to be looking at a custom neural network, one that's built entirely within the ServiceNow platform.
Yeah.
It's like having this mini brain working inside your IT system.
Okay, so this isn't just like a random project, right? This is something bigger.
Oh, yeah, definitely.
This was created by Anders, a ServiceNow MVP. He's a big believer in that learn by building approach, so he actually went and built this entire neural network himself to solidify his own understanding.
It's a fantastic example of hands-on learning. What Anders has actually built. It's a custom neural network application. It allows users to create their own networks. So users can define layers, inputs, outputs, really customizing it for their own prediction and classification needs.
So not something that's going to generate images or write poetry, but more focused on analyzing data and making decisions based on that data.
Yeah, and it's important to note that this isn't publicly available just yet. It's still on Anders' personal ServiceNow instance. But the exciting part is he is planning to release it to the community.
So you're telling me there's a chance that I could be using this thing in the future?
Oh, absolutely.
Now that's what I call a valuable deep dive.
Exactly. And that's why we're going to be diving into the details of his project. We're even going to take a look at some of the source code.
Okay, let's unpack this a bit. So Anders builds this whole network from scratch to learn about neural networks. What were some of the biggest hurdles that he faced along the way?
Well, one of the most important lessons he learned was the importance of data, specifically balanced data. Initially, he was training his network on a data set of incidents from his own ServiceNow instance. But this data was heavily skewed towards a specific assignment group.
So because most of the incidents were already assigned to that group, his model just kept predicting that same group for every new incident.
Precisely. He realized that without balanced data, his model couldn't generalize well. It's like training a model to recognize images of birds, but only using pictures of penguins. It might think that all birds are flightless and live in Antarctica.
Oh, okay. So that balanced data is key for creating a model that can actually adapt to new situations.
Absolutely. Now, to really understand how he tackled this and other challenges, let's look at the structure of his neural network. So he's actually provided the source code for a neural network, a layer, and even a single neuron. And while we won't go line by line, it's there for those that want to get into the nitty-gritty.
It's like having a blueprint to a mini brain right there in front of you. But before we get lost in the code, can we talk about some of the core functions of this neural network? What are the basic actions it can perform?
Of course. So the key functions are initialize, load, train, predict, and save. Each of these plays a really crucial role in the network's operation.
All right, so let's start with initialize. What's happening when the network is initialized?
So initialize sets up the neural network's learning environment. It establishes the learning rate, which dictates how quickly the network adjusts during training. And it creates the layers based on what the user defines, or if they're loading a pre-existing network. This is where the basic structure of our mini brain is established.
Okay, so initialize is like setting the stage, getting everything ready to go. What about load? Does that have something to do with those pre-existing networks you mentioned?
Exactly. Load allows you to retrieve a previously saved neural network. This is particularly useful if you've already invested time in training a network, and you want to reuse it without starting from scratch.
So instead of training a new network every time, you can just load a previously trained one.
Exactly.
Interesting. Now, train. That sounds pretty self-explanatory. Is this where the network actually learns?
You got it. Train is where the magic happens. This is where the network learns to perform its task. You can think of it like teaching a student. You provide them with sets of problems and their corresponding solutions.
So for this neural network, would that be something like feeding it data about incidents and telling it which assignment group those incidents belong to?
Exactly. The network goes through these examples, and it makes adjustments to its internal connections to improve its accuracy with each round of training. Each of these rounds is called an epoch.
Ah, epochs. Now I understand why I mentioned that earlier. So it goes through multiple epochs, fine-tuning itself to get better at its assigned task.
Precisely.
Yeah.
And once the network has gone through enough training, it's ready to make predictions on new, unseen data. That's where predict comes in.
Okay, so predict is using all of that learned knowledge to make informed guesses about new data that it's seeing for the first time.
You could say that. It's like giving a student a test after they've studied the material. You want to see how well they can apply their knowledge.
That's a great way to think about it. Now, what about save? What's the purpose of that function?
Well, once you put all that effort into training your network, you don't want to lose all of that progress, do you?
Definitely not. That sounds incredibly frustrating.
Exactly. So save allows you to store your trained network for later use. That way, you don't have to retrain it every time you need to make a prediction.
Makes sense. So we've got initialize, load, train, predict, and save. Those are the basic building blocks of this neural network. But I'm curious, what are the real-world implications of this? What can you actually do with this network within the ServiceNow environment?
That's a great question, and one we'll explore further in the next part of our deep dive. Stay tuned.
Okay, so we've got those basics down, like how this custom neural network works. But now I'm really interested in the practical applications here. What can we actually do with this thing in ServiceNow?
Well, the possibilities are really quite vast. You think about all the data that flows through ServiceNow on a daily basis. Incident reports, change requests, user logs, and so much more. This neural network can really sift through that mountain of information and find those valuable insights that would take humans ages to uncover.
So it's like having an incredibly efficient, data-driven assistant just constantly working in the background.
That's a great way to put it. For instance, imagine you want to improve your incident management. Well, this neural network could analyze past incidents, pinpoint those recurring root causes, and even predict the most suitable assignment group for new incidents that come in.
That would be a game changer for efficiency, potentially slashing resolution times. I'm starting to see how powerful this could really be.
And we're just scratching the surface. Think about automating tasks. It could analyze incoming incident reports, categorize them automatically based on the content, and then route them to the right team.
So it's not just about insights, it's about actually taking action based on those insights. This is starting to feel like something out of a sci-fi movie, but it's real and potentially right around the corner.
That's the beauty of it. It's about harnessing the power of this data that we already have and using it to drive meaningful action and optimization. And this is really just the beginning. As people start to experiment with this custom neural network, we're likely to see even more creative and innovative use cases emerge.
Yeah, it really feels like it could give anyone using ServiceNow a significant edge in their work. What I find particularly impressive, though, is that Anders built all of this using custom code, like no external frameworks or APIs.
Yeah, it's a testament to his deep understanding of both neural networks and the ServiceNow platform itself. And, the fact that he wants to make this publicly available really speaks volumes about his collaborative spirit and his desire to really empower others. It's this kind of open sharing that fuels innovation.
It is really inspiring to see someone so dedicated to sharing knowledge and helping others. What excites me the most is the potential for this to become a springboard.
Yeah.
For other people to create their own solutions.
Absolutely. This deep dive, it isn't just about understanding one specific neural network. It's about understanding the broader potential of AI and machine learning within the ServiceNow ecosystem. This is just a prime example of what's possible.
It's like opening a door to a whole new world of possibilities. Now, what I'm curious about is the source code itself. We mentioned earlier that we wouldn't be going line by line, but it is available for anyone who really wants to dive in.
Right, and I think it's important to highlight how valuable having access to that source code really is. It's like having that behind-the-scenes look at how everything works.
Can you elaborate on that a bit more? What specifically makes the source code so valuable in this context?
Well, it allows you to see exactly how the neural network is implemented. You can trace the data flow, see how the different functions all work together, and even experiment with modifying the code to see how it changes the network's behavior.
So it's not just a black box. You can actually see the nuts and bolts of how it works. That must be incredibly valuable for anyone who's really serious about learning about neural networks.
Absolutely. For those who really want to master neural networks, I would highly recommend spending time with that source code. It takes you beyond theoretical understanding and lets you see those concepts translated into functional code.
It's a level of learning that goes beyond just reading or listening. It's about active engagement and exploration. This has been a truly fascinating deep dive so far. We've explored the potential applications of this custom neural network, highlighted the value of the source code, and even touched upon the broader impact of AI and machine learning within ServiceNow.
What strikes me is the power of learning by doing. It's Anders' philosophy in action. He didn't just read about neural networks, he built one.
Yeah.
And through that process, he's really achieved a level of understanding that wouldn't have been possible through theory alone.
It's a great reminder that sometimes the best way to learn is to simply dive in and get your hands dirty. Speaking of diving in, I'm really curious to hear your thoughts on the bigger picture here.
Well, throughout this deep dive, we've been focusing on Anders' impressive work and his decision to share this neural network with the community. You know, this open collaboration has implications that extend far beyond this particular project.
That's interesting. Can you unpack that a bit? What makes this open sharing so significant?
Well, think about it. It's about making powerful technology accessible to a wider range of people. Imagine a world where anyone, regardless of their technical background, could harness AI and machine learning to solve problems and innovate.
That sounds incredibly empowering. But how does this specific custom neural network fit into that larger vision?
Well, by making the source code and the application itself publicly available, Anders is essentially offering a blueprint, a foundation for others to learn from, to experiment with, and build upon. It's about democratizing access to this technology.
So it's not just about using this one neural network, it's about inspiring a wave of new solutions, tailored to individual needs and challenges. It's about fostering a community of shared learning and collaboration.
Exactly. You know, where knowledge is freely exchanged and innovation flourishes. It's like planting a seed that can grow into a whole forest of new ideas and applications.
That's a beautiful way to put it. I think this really highlights what's so exciting about this deep dive. It's not just about the technology itself. It's about the ripple effect it can create. It empowers individuals and organizations to reach their full potential.
It really does. And it reminds us that innovation often thrives in environments of openness and collaboration.
Now, before we wrap up, I want to leave our listeners with something to think about, a question to ponder as they continue to explore the world of AI and machine learning.
I'm all ears.
What could you create with this knowledge? What problems could you solve?
That's a fantastic question. It's a call to action, an invitation for our listeners to become active participants in shaping the future of AI and machine learning.
Precisely. Don't just be a consumer of information, be a creator, be an innovator. Use what you've learned from this deep dive and apply it to your world.
Experiment, explore, push the boundaries of what's possible. And remember, you don't have to go it alone. Embrace that collaborative spirit. Share your ideas. Learn from others. You might just spark the next big breakthrough.
And on that note, this has been our deep dive for today. We've explored the world of custom neural networks, witnessed the power of learning by doing, and glimpsed the transformative potential of open collaboration.
And we've challenged our listeners to take this knowledge and create something amazing. We're eager to see what you come up with.
Until next time, keep diving deep, keep exploring, and keep pushing the boundaries of what's possible. You know, it's really inspiring to see how Anders is empowering others by sharing his knowledge and his creation. It makes me think back to those key functions we discussed: initialize, load, train, predict, and save. They seem so straightforward, but I bet there's a lot of complexity going on under the hood.
Or absolutely. Each of those functions represents a pretty sophisticated process. Take train, for example. It's not simply feeding data to the network. It actually involves a lot of intricate calculations and adjustments happening behind the scenes, constantly refining the network's understanding of that data with each epoch.
You mentioned calculations. Can you give us a little peek behind the curtain there? What's actually happening during that train function?
Well, one crucial concept is gradient descent. It's a mathematical process the network uses to adjust its internal connections and minimize errors as it learns. You can think of it like trying to find the lowest point in a valley. The algorithm iteratively adjusts its position based on the slope of the terrain until it reaches the bottom.
So in the context of the neural network, the valley represents the ideal configuration, where the network is making the most accurate predictions.
Precisely. And the slope represents the error that the network is making. With each epoch, the network uses gradient descent to adjust its parameters, essentially taking smaller and smaller steps down that slope until it reaches the most accurate configuration.
That's a great analogy. It really helps to visualize what's happening during that training process. Makes you appreciate the complexity involved in making these networks actually work.
It certainly does. And remember, this is just one aspect of one function. There's a whole world of fascinating mathematical concepts and algorithms at play within each of those functions.
Well, maybe we can do another deep dive sometime to explore those mathematical concepts in more detail. But for now, I want to shift gears a bit and talk about the potential impact of this custom neural network, particularly for those of us who aren't programmers or data scientists.
That's a great point. You know, we've been talking a lot about the technical details, but it is important to remember
that the ultimate goal of technology like this is to improve people's lives and make things easier.
Exactly. So for someone who maybe doesn't understand all the intricacies of neural networks, how could they potentially benefit from this technology?
Well, imagine you work in IT and you're constantly bombarded with these incident reports. You know it can be overwhelming to sift through them all and prioritize them effectively. This neural network could analyze those reports, categorize them, and even suggest solutions based on past incidents. It could really free up your time and mental energy to focus on more strategic tasks.
That sounds incredibly helpful, especially in a fast-paced work environment. It's like having a tireless assistant who can handle all those repetitive, time-consuming tasks.
Exactly. Or let's say you work in customer service. This neural network could analyze customer interactions, identify patterns in complaints or feedback, and even suggest proactive measures to improve customer satisfaction.
It seems like the possibilities really are endless. It's all about finding creative ways and to apply this technology to solve real-world problems.
Precisely. And that's what makes this so exciting. We're really just beginning to scratch the surface of what's possible. With AI and machine learning, the future holds immense potential for innovation and positive change across countless industries.
I think this has been a truly enlightening deep dive. We've gone from that theoretical understanding of neural networks to seeing a real-world example built within ServiceNow. And we even touched upon those complex mechanisms at play within those seemingly simple functions.
And hopefully, we've inspired our listeners to think about how they can use this knowledge to create something new and impactful.
Absolutely. So to our listeners, thank you for joining us on this deep dive. Remember, the power to innovate lies within you. Don't be afraid to experiment, explore, and push the boundaries of what's possible.
Until next time, keep diving deep, keep learning, and keep creating.